Let's look at some of the terminology in Docker. So first thing is on the left side, you have your application code, classic application code. It can be written in Java, Python, Node.js, C Sharp, PHP, .NET, any other technology. Just you have to name it and it's supported. And then you have to write a file called Docker file, exactly with the same name on the same root level of your source code. In this Docker file, you write some instruction. You write some plain English text instruction, what has to be done, how the application code, how the configuration that is needed by the application code, how the runtime of the that's needed by the application code, all this how part and from where it can be fetched. You write those instructions in this file. All right. So now this is a file like your, let's say, .java file or .py file or .js file. It's just another file, Docker file. It cannot do a magic of its own. Then we convert this Docker file into a Docker image by running a command. Don't worry about the command. We will look at them in detail later. But with one command, we tell the Docker engine convert this whole application and the dependencies and the configuration and other stuff into an image. That's called a Docker image. And we create a specific version of this image, which means if there's another change to the application code or the Docker file, you run the same command again and a new version of the specific Docker image is created. All right. So let's say in our case, the application was Java Spring Boot with a Docker file in it. And then you ran a command, it created a Docker image for that Spring Boot application. If you modified the code, build the code again, run the Docker image command, Docker build image command, it will create a new version of the same Spring Boot application. And what does the Docker image has? It has the code, it will have the tools and utilities, it will have the configuration. So it has everything that it needs to live in an isolated environment. In an isolated environment, that's what we saw. So this Docker image has everything, but it's still not running. Like the code, it was still static, just file on the file system. This is not exactly on the file system, but somewhere inside Docker engine, it is just sitting there. It's not doing anything. So you can keep a copy of this in your local Docker engine, like, or you can also push it into Docker Hub registry. Like, let's say in case of Maven, you have a Maven central repository where different dependencies are available. You either do a, when you do a Maven clean install or build, the dependency get downloaded. Similarly, when you build your application, you create the dependency of your own application and push it there. Let's say in case of Node.js or Python, you also in the Node.js, you have the NPM registry where you pull the dependencies, packages and dependencies, and also push your dependency later on, your application dependency. Same way, we also have a registry for Docker, pushing the Docker images. So it's called Docker Hub registry, where you can pull some images that you need and also push the images. So this is public, but there are also private repositories, like one in your local, but maybe with the cloud provider. In Azure, we have ACR. In AWS cloud, we have ECR. So those kind of repositories are also there. Next is, now, what if we want to do something, we want to do something with this image, right? Otherwise it's of no use, it's not running or it's not helping. As soon as we run this Docker image with a command, it starts to create containers. And containers are the actual living being or living entities of this application. This application with this configuration and this tools and utilities, all this come into real life existence with the help of containers. So the container, this container one will run the exact same copy of this Docker image specific version. Container two will also run the same. Container three will also run the same. There can be n number of containers. That's the power of scalability, modularity and scalability. So that's what is this image about. If you see, these are containers, small boxes that you see. They're just sitting on top of Docker engine. So Docker engine is running them on your host operating system. So if I install a Docker engine on my machine, I will download the Docker engine for Windows operating system, which will be able to run my Docker containers. If you have a Mac, you download the same thing and take my Docker image from, let's say, Docker Hub, and you can run it there on your computer, and it will, like that image will know how to set up the code with configurations and utilities. So that's the power of run anywhere here. So Docker containers are the real world living entities. They occupy memory and space. Docker image is the bundled version of, let's say, your source code with utilities configuration and other stuff. Docker file is the script that you write, the instruction that you write about what all things should be part of the image, or maybe in exact terms, what exactly things are needed for running your containers in when the containers will come to alive. What are the all the other things that's needed? You write those instructions here. So this was all about terminology and different components of Docker, Docker file, Docker image, Docker containers. Of course, there can be multiple containers running. So let's say there's a container running for your application code, let's Spring Boot, but there's also a Docker image which has produced a Docker container for the database. Now your application needs to talk to the database. That's why it's mentioned here, containers are isolated from one another, but they can also communicate between each other with the well-defined channels. Like here, when we do software development, we also connect to databases, and databases are running separately. Similar way, we can run database as well, but in another container, in another database will have its own image, Docker image, and it will run in another Docker container. And so the application Docker container can talk to the database Docker container in real time via proper channels. So this was about details of various terms in Docker.